So with stoichiometry, we can get a little bit deeper in. I know we had the video of Mr. Darby earlier on 12.3, but with 12.4, we get a little bit more complicated. We still had to balance, so we still had to find all of our balancing. Remember, as long as you know what you're doing, you really don't have to do all of the table anymore, but if you want to, you're more than welcome to. So on this one, I have 1 and 2. I have 2 and 2. I have 1 and 1, and I have 2 and 1. So I can try with my silver first, but if you see, silver is by itself, so this is going to be pretty easy to fix if we just get to the end. So let's try with our O2 first, and what we will do is go ahead and fix that. So that fixes our O2, but it messes up our H. It does mean that we have to put a 2 on this side, so we fix our H, but now we messed up our S. So let's go ahead and put it here and fix our S, but now it screws up our AG a little bit further, but AG is a nice easy fix because the 4 goes right there. Okay, so my ratio is 4 to 2. Remember, this is a 1 and then 2 and then 2. Okay, so what is the mass in grams of Ag2S from our 23 grams of H2S? Now, remember, all the fence post method it's all about trying to get rid of our symbols, trying to get rid of symbols from something else. So we know we're going to want to finish with our grams of silver sulfide. So that means we're going to have to use our molar mass, because remember, if we go back, we have all of our moles equal molar mass, our 6.02 for molecules, and our 22.4 for our liters. Now with this, so we have to find Ag2 times, if we look at our periodic table, it's 107.9, and then we have S, which is 32.1 times 1. So we have our 215.8 plus our 32.1. So we're going to end up having 247.9 as our answer right here. Okay, so that's, and long story short, that's what we get for our molar mass for our finishing. Now remember, because it's molar mass, we need to put 1 mole of Ag2S here. We are always going to put our 1 mole of whatever it is, no matter if it's in liters or if it's in molecules or mass. We're always going to put 1 mole of whatever we're trying to get to on the bottom, because we're going to want to cancel it out eventually. So with this, we need to cancel out H2S. So remember, H is 2 times 1, and then S is still 32.1, so it's just 34.1 grams of H2S. And that's for every 1 mole of H2S. So we've gotten to the point where we can get rid of our grams, get rid of our grams. We have crossed those out. So we don't have to worry about grams of H2S anymore. But we have to get rid of our moles of H2S. This is where our molar ratio comes in. So if we look at H2S, we see that we have 2 moles of H2S for every 2 moles of Ag2S. Okay, so that means we can get rid of our moles of H2S. We have now transformed it into moles of Ag2S, so we can get rid of that because we see it down here as well. So that means whatever our answer is will be finalized in that grams of Ag2S. Okay, Nice thing is that these two cancel out, so we can just call them ones, because 2 divided by 2 is 2, or 2 divided by 2 is 1, sorry, and that's not going to matter anyway. So all we're doing for the math, which I care a little less about, I care more about the process than the destination, we are going to have 23 divided by 34.1 times 247.9. Okay, so always the goal is to try to get it as simplified as possible. So by using this Finch-Post method, we're able to get rid of stuff. So if we look at one that's talking about 118 grams of silver, so that's where we start at, and we are trying to get to our final destination, which is 22.4 liters of oxygen. Now remember, we don't need anything to do with molar mass for oxygen because we're only talking about liters. So we know nothing about grams. The only thing that we have to find grams of is silver, and we know based on this up here that silver is 107.9 grams for every 1 mole of silver. And we know that oxygen for 22.4 liters, 1 mole, is always at the bottom of our final step. Now, we can get rid of the grams, and now we want to get rid of the moles. So if we look up back at our molar ratio, we see that there are 4 moles of Ag for every 1 mole of O2. So that means we can get rid of our moles, and we can get rid of our moles of O2 as well. So that means our final answer will be the only thing that's left, and that's liters of O2. I believe it's like 6.12 or 6.12, I mean, for the answer. Once you go through and divide 118 by 107.9, divided by 4, because it is a 1 to 4 ratio, and then we have multiplied by 22.4. Okay? Now, last thing is talking about molecules, and it has 3.56 grams of H2S. And we're trying to turn that into molecules, and because it's molecules, that's where we use the 6.02 times 10 to the 23rd molecules of Ag2S. And of course that is always in 1 mole. Now the nice thing is we know that we're using the same, because it's H2S, same molar mass as before. So we can just go ahead and cheat, use that. No reason to do more work than you have to for every 1 mole. And this is Ag2S, H2S. And now what we will do is we will take this and we just do the molar ratio. The nice thing is it's the same molar ratio as before, because we're still doing, we need to get 2 moles of Ag2S, and we need to get 2 moles of H2S, and we're getting rid of our grams because they cancel out. We get rid of our moles of H2S because they cancel out as well, and we get rid of our moles of Ag2S. And that means our final answer will be in molecules of silver sulfide. So, based on what we're given, we should be able to go step by step to cross out whatever answer or whatever question we don't want. Okay? So, if you have any more questions, I'll post another video with a little bit more direction on how to do even more on this with 12.4a, and we'll go ahead and go from there. Alright, I'll post a video after that for that shortly.